It's the MyMichelleLive Podcast.
MyMichelleLive, Sci Tech Talk, taking the God story to a geeky place. Here's Michelle.
Hey, glad to have you at Sci Tech Talk as we talk about some of the big news stories that's impacted the scientific world. How does God's word and the God story impact science? Do they work together? Is it a clash of titans, or is there a beautiful symmetry throughout the entire universe? You know where I'm going with that. But this is not just about Michelle's opinion. We want to bring in the big guys, the thinkers, the scientists, the people in the know. And this man has been on my show for years, countless times. He is such a delight. He's become a friend and someone I pray for daily. Dr. Hugh Ross, he's the founder of Reasons to Believe. Thank you for hanging out with me today.
Oh, it's been my pleasure, Michelle.
Let's talk about some of the big news stories. It seems that we are in another space age. SpaceX is on track to launch. They have 5 Crew astronaut mission, and it is tomorrow that they're looking for launchers. A few things that they're working through. That's huge. NASA is gearing up for a base camp. They're literally looking to go to is it the southern region of the moon?
Yeah, the South Pole.
The South Pole, the cold, dark, over bright at times, extreme, probably like our South Pole, maybe the most extreme part of the moon. And base camp, which to me is fascinating. Think of all of these possibilities that have gone through our minds and we've watched in sci-fi films. These are really big stories and they're happening right before our eyes. Additionally, the International Space Station, it's getting old. They are trying to extend it. They thought it would only last to 2028. When you think about it, just a couple of years away. And they're like, oh, I think we can extend it. Russians were saying, hey, there's cracks here. We've got some problems. I've got cracks sometimes in the foundation of my house, but that's a big, huge difference. This is big stuff that we're doing, Hugh.
Yes, indeed. A few cracks in your home is one thing. Up in the space station, that could be catastrophic.
It's funny to me how they had to take into consideration some of the extremities of space, asteroids, extreme temperatures, and how that would affect some of the materials that make up all of these things, a base camp, the International Space Station. It's amazing to me the extreme nature of space and the ease and beauty and simplicity of life on Earth. That contrast to me is, wow, mind blown.
Well, as Neil deGrasse Tyson has said, the universe is out to kill us. Once you get past planet Earth, everything is incredibly dangerous.
It kind of feels that way too. Let's just delve into SpaceX very quickly. What is SpaceX plans and how likely are they to succeed?
Both SpaceX and the NASA big rocket Artemis are designed to put people into space and get them to places like the moon and Mars, so that the whole focus is people in space. And we're no longer in the 1970s. I read the article about putting this base on the moon, and it's like, in the past half century, we've developed technology where we're interested in science. We no longer need to send people. Machines can do it far more cheaply, much more quickly, and generate far more science than what we're going to get by sending people.
Okay.
And I think Neil deGrasse Tyson's got a point. Once we get people outside of Earth's magnetosphere, trying to keep them alive is a real challenge. Whereas if we send machines, nobody dies. If something goes wrong, you send up another machine. And we're basically looking at saving the taxpayers tens of billions of dollars. Because the machines, we're looking at a few million. With people, we're looking at tens of billions.
Interesting, because we just have this desire, though, to go into space, don't we? We have that desire.
I'm for that.
right?
I'm a scientist. I want to learn what's going on in the moon and the universe. I
But
wrote
you
an
want to
article.
see it and you want to touch it and you want to be there. I understand, and I love the idea that the waste of human life wouldn't be there if we send machines out. But we still have that desire to see, to touch, to experience that adventurous spirit, which interestingly to me, I think does set us apart from the rest of the animal culture on our planet, doesn't it? I don't see,
Well,
even
it
though we've
does.
shot monkeys into space, I don't see them like building rockets.
I think that's part of what SpaceX is all about too, is space tourism, getting people to have the experience of being in outer space.
Would you do
And
it?
I think there's a better use of money than this. So I would use my money in a different way. And
Come on,
it's
because you know
okay.
what? There's a better use of money in the grand scheme of things. There's people who need help, but we still go to Disney World and Disneyland and
We
on the
do.
right.
I'd be fine if it's only a few hours. I'm concerned if it's more than that, because when you're in zero gravity, your body begins to get used to that lower gravity. And when you come back, it's going to be a problem. And then you got the radiation exposure. So I would be just as fine looking at the beautiful photos and not being exposed to all that radiation and the microgravity. And if you want to experience zero gravity, you can always go up on the Vomit Comet. There's a special aircraft that will take you up, and you could, I think, yeah, for a modest sum, they'll allow you to experience weightlessness 8 times for 40 seconds each.
I can't imagine what that costs, but at
No,
this,
it's not that expensive. I got
what?
friends that done it. Yeah, yeah. I think it's less than $1,000 you have to pay to have that experience.
And that's doable for most people. If you scrimp, you save, even people with low income. If that's your dream. That's amazing that you can do that.
All
As
you need is an aircraft doing parabolic motions in the sky. That'll give you weightlessness.
I'm already
And
not feeling good.
oh, a friend of mine was warned that you're probably going to throw up the first couple of times, but she did fine. She had 8 weightless experiences, and she said my stomach was fine. So
I would love to experience it. And as we move into this seemingly new space age, it is very different, markedly different than in the 1960s when I didn't, but we as Americans sat in front of our televisions and or went to Cape Canaveral, wherever the rockets were launching, and you feel the rumble from your feet to the sole of your gut, and you smell the rocket fuel, and you watch this thing launch into space. And why did we do it? Basically, as the president of the time, JFK, said, we're doing this because we can. Because that was the
well,
famous speech.
I watched those men walk on the moon back there in 1969. And there was some scientific rationale for sending people, because we didn't have the technology to recover hundreds of pounds of lunar rocks any other way. Today we do. And I spoke at NASA Houston back in 2005, I think it was, basically saying we need to go back to the moon. We need another Apollo mission. But this time, let's have the goal of recovering Earth's soil from the moon, not the pristine lunar rocks. Because in that Earth soil, we're going to have the pristine fossils of Earth's first life. And Earth's geology has completely destroyed those fossils here on Earth. But thanks to meteorites impacting the Earth, there's about 20,000 kilograms of Earth's soil on every 100 square kilometers of the moon's surface. So I'm excited about going back to the moon. Let's recover that Earth-transported soil, and let's look for those fossils and see who got the origin of life model, the theist or the atheist. As I shared with NASA back then, I said, last time I checked, atheists and theists made up 100% of the US population. So everybody should be thrilled about you guys at NASA going to the moon and solving one of the biggest debates on our planet. You can do it. And we don't have to send people. It could all be done with machines.
Is that
And hey,
crazy? So let's talk a little bit more about that. The importance of what we're doing goes twofold. Just this show, Hugh, we talk about the science, what's going on. It titillates our imagination at times and fills our brains with information. But there's also that God story side. Let's talk a bit about the moon base. They look at doing mining and exploration. Let's talk about some of the cool things we'll discover. But let's talk also about more of that God story that you're talking about.
I like the idea of going to the South Pole because there's a crater there with walls so high that it gets no sunlight, which that's why there's water there. There's frozen water there because it never gets warm enough to melt. So when comets sit there, the ice accumulates. And they're thinking we can use that for humans need water. We can split the water into hydrogen and oxygen. Oxygen we can breathe, the hydrogen we can use. But the fact that the sun never shines at the bottom of the crater floor, that tells me that's an ideal place to put a telescope. And it's getting harder and harder to do optical astronomy on the Earth because of light pollution, especially with these LED lights. The night sky is getting so bright that it's hard to see anything, and it's a worldwide phenomenon. But if we go to that South Pole crater on the moon, there'll be no light pollution. Moreover, it's going to be super cold, which means that we astronomers need to keep our detectors at an extremely cold temperature, just like they did with the James Webb Space Telescope. They had the sun shield in order to keep the detectors super cold so they could have high detection. So that crater at the South Pole is an ideal site to do astronomy. But one thing we've learned from doing that millimeter wave array in Chile at 17,000 feet, we can construct it without any humans being on site. And here we got this huge array of radio telescopes in Chile. It was all assembled by helicopters dropping everything into place. Nobody had to be there. And at 17,000 feet, you really don't want people there. It's a dangerous place to be. We can use the same technology we developed in Chile to build a telescope in that South Pole region without human beings having to be there.
That's astounding. And we can talk about what can we see there. I think of life on our planet and how light pollution has drowned out our ability without telescopes to see with the naked eye. What people 100, 1,000, 5,000 years ago were able to look up and see. We have segregated ourselves a lot from creation. And you often talk about how that seems to have a direct effect and on our ability to relate to God.
It does. The Bible tells us the heavens declare the glory of God. The heavens declare the righteousness of God. His attributes are revealed in the heavens. But if you live in a really big metropolitan city, you can look up in the night sky on a clear night and not see a single star. For a lot of people in the 21st century, the heavens aren't declaring anything at all. On the other hand, we have things like the James Webb Space Telescope, the Hubble Space Telescope, the Atacama Array in Chile. And so thanks to these instruments, we can see God's glory revealed in the heavens. And that's one reason why I'm so passionate about showing people these amazing images, explaining to the science, because this is a way that they can actually see what's happening in the heavens. Let me turn that off. Hang on.
Oh, absolutely. If you're just joining in, we're having fun talking space with Dr. Hugh Ross. He's the founder of Reasons to Believe. And as a scientist, this is super exciting times. As you're mentioning, we can see things beyond what not only can we not in our planet, as we mentioned, there's a lot that you can't see, right, with the naked eye. But with technology, we've been able to see more. So it's that interesting dichotomy.
It is. It's a counterbalance. Those of us who live in big cities, we can't see much with the naked eye, but we got technology. I have a telescope that I take out on the street, and it just attracts a crowd. I let people look through the eyepiece, and they get to see, they have a spiritual experience when they look through the eyepiece. The heavens really do declare the glory of God. When you recognize just the awesomeness of what's out there, how all of it is necessary for us to be live here on planet Earth. Yes, the universe is out to kill us, but we have this one little place within this vast universe where we can live, we can thrive, and discover our purpose in the universe.
Now, Hugh, it's interesting that you mentioned that. I'll see if I can pull up this visual for those who are watching the video. But there was an article put out by Expert Voices, Chris Impey. His article is entitled Super Earths Are More Common and More Habitable Than Earth. Astronomers are finding more of the billions that are out there. So he's saying that there are billions of super Earths, and that means Earths that are bigger. Some of them have a shorter rotation around the sun, and that the one that shocked me is that they're more habitable, which begs the question, then why aren't they inhabited? But I'd like to get your thoughts on that based on what you had just said, and you've written about this very issue.
Yeah, I have in my book, Designed at the Core. It's my latest book, just came out a few weeks ago, making the point that what's unusual about our solar system, it doesn't have any super Earths, and it doesn't have any Neptune-sized planets that are close to the sun. That's a common feature when we look at extrasolar planetary systems. They have huge numbers of these planets that are more massive than the Earth, but less massive than Neptune. They typically orbit fairly close to the star. And if that were to happen on our solar system, throw in one super Earth, there'd be no life possible here on planet Earth. So it's actually a problem. And the thing about super Earths being more habitable, it was a presumption that you'd have plate tectonics, but new papers have been published showing planets less massive than the Earth and less dense than the Earth are not going to have the plate tectonic activity of the Earth, and planets bigger won't either. You have to fine tune the mass and the density of the planet to get long-lasting, strong plate tectonics, which is an essential feature, maybe not for microbes, but it's an essential feature for plants, animals, and human beings. And one of the big unrecognized problems with super Earths that are water rich. And we found a couple of planets that are about the same mass of the Earth and orbiting their stars about the same distance. Their water content comes in at about 500 to 1,000 times greater than the Earth. And when you got that much water, we're all taught in school, ice floats. Not if you got a whole lot of water. If you got a whole lot of water, you'll get ice on the surface and you get ice on the bottom. But the ice on the bottom, because of the pressure of the water above it, is permanent. So you get a permanent barrier separating the water from the rock, which eliminates any possibility for life on that planet. You say, how much water do you need for that to happen? If you got about 15 times as much water as planet Earth, you're going to have an ice shield at the bottom of the ocean separating the liquid water from the rock. And what we're discovering so far with these super Earths, it's not just a factor of 15, it's a factor of many hundreds of times water. And we now know that Earth actually began with that much water. So Earth started off with oceans that were thousands of kilometers deep, which meant you would have that ice at the bottom. But because our proto-Earth collided with Theia, our solar system began with 5 rocky planets. 2 of them collided together and made the Earth and the Moon, but that collision event caused Earth to lose over 99% of its water and 99% of its atmosphere. And again, too thick of an atmosphere, likewise, is a huge problem. That means it's going to be too hot on the surface.
So basically, we look at some of these exoplanets, or what they're calling super Earths, and we realize it's just not that simple. It takes a lot of happenstance, incredible coincidences, just the right tweaking in just the right solar system with just the right suns, in just the right positioning of the planet, in just the right portion of the universe for life to even not only be possible, but to have the kind of diversity of life. And so I wonder why this article came out just 2 days ago. And you say, hey, we know all of this information, but the author is a professor of astronomy, studies galactic cores, distant galaxies, astrobiology, and exoplanets, and closely follows the search for planets. So why does he say that these planets are much more habitable?
He's thinking that, hey, they're going to have more water. But again, I'm making the point, too much water is a problem. Too little water is also a problem. It's got to be highly fine-tuned. And then the plate tectonics, I think what he's doing is he's citing literature basically that dates back several years, making the point that a planet a little more massive than the Earth will have more plate tectonics. But a paper just got published refuting that, saying, no, if the planet is bigger than the Earth, you're going to get what's called a rigid lid. And you get a rigid lid if it's smaller. You have to actually fine-tune the mass for that to happen. And also, I think a lot of these astronomers, they isolate the planet. And you just made the point. It's not just the planet we need to look at. We need to look at the star. Does a star have the right characteristics to make advanced life possible on a planet orbiting it? And what I'm writing about in Design to the Core, another big factor is all the other planets. So we know we need to find not just an Earth twin. We need to find a solar system twin, because we now know that all 8 planets in our solar system must have fine-tuned characteristics for life to be possible on Earth. Make Mars slightly different, we have a problem. Make Venus slightly different, we have a problem. Make Uranus slightly different, we have a problem. Moreover, the 5 asteroid and comet belts that are in our solar system likewise must be fine-tuned. As we look at other planetary systems, they either have no asteroid and comet belts at all, or they have asteroid and comet belts that are 1,000 times bigger than we see in the solar system.
Ooh.
In both cases, it's catastrophic for advanced life. And so you need to look at the entire system, not just the planet, not just the star. The moon is important. If you don't have an Earth-Moon system, a planet-moon system identical to the Earth and the moon, there will be no possibility even for microbes on the planet. And so unless that super Earth is exactly the mass of the Earth, the same density of the Earth, with a moon that's exactly the same as our moon, forming in the same way, you're not going to have even microbes on that planet possibly exist.
Crazy coincidence, or thousands, if not millions of coincidences. And that seems to destroy his other argument that, wait a minute, look at the Earth. It's been inhabitable for much of its existence. It's only been recently that the Earth relatively recently, if you look at what he thinks is the longevity of the planet, he said it's only been habitable relatively recently. And that also plays into the God story, doesn't it?
Yeah, because we've actually had life on planet Earth for 3.8 billion years. We've had plants and animals for 580 million years. So it's not just a short time. It is, we humans have been here for a very brief time. But life has been abundant on our planet for a long time. If it wasn't for that abundant life, we wouldn't have the biodeposits to launch civilization. And trying to get a planet that's got life for 3.8 billion years, that requires extraordinary fine-tuning, as you mentioned, of hundreds of different features of the planet-moon system.
And interestingly, it plays into a God story in God's plan, the perfection of not only habitability, but diversity of life and resources that happen to coincide with the rise of man, so to speak. It plays into the history of past, present, and future of the gospel.
Really does, in the sense that when we look at the fine tuning, it's at a certain level to get microbes that can exist for maybe a year on a planet. But if you want the microbes to exist long enough to chemically transform the planet to make plants possible, the level of fine tuning goes up exponentially. And if you want animals, you got another exponential increase in the required fine tuning. And if you want humans, you see a tremendous exponentiation, but the greatest exponentiation of all is the design you need in the universe, our galaxy, our planetary system, in order for billions of humans to live on the planet and to have the technology where those billions can be redeemed from their sin and evil. There's the real God story. When you look at fine tuning and see the level of fine tuning that's necessary, we see that it's at its highest level in the context of a redemptive creator, a creator intent on redeeming billions of human beings from their sin and evil.
Do you find it fascinating too within this God story that as we seem to wane from faith in our society, technology continues to advance, and so do discoveries that coincide with a biblical worldview?
Michelle, what I'm sharing with my secular peers now, I'd say, look, I know you're not a Christian like I am, but if you will do your scientific research from a biblical redemptive worldview perspective, it will make you a more successful scientist. You'll be more successful in making scientific discoveries. And if you don't believe me, put it to the test. Try it and see what happens.
Prove me wrong.
Of
Go
course,
ahead.
yeah, prove me wrong. But what I'm discovering is they say, wow, this really does work. And it causes them to say, maybe I need to think about this Christianity.
I love that. And that really runs true with all of us as you're watching, listening, reading. If you look at the world of science, psychology, whatever's happening in the evening news through a biblical worldview, just examine it, prove us wrong. But what you will find is that there's a continuity, just as there is, and Hugh and I will often talk about this continuity in all of the universe. No matter where you go, there are the same laws, the same rules. It's beautiful. The symmetry, the continuity is all there. You'll find that. So I challenge you, if you're not part of this crazy God story, prove us wrong. See where you come to your conclusions. I find it really fascinating. Hugh, this has been a delightful conversation. I still have a billion questions in my mind, but I'm sure we'll have the opportunity to sit down and talk again. Thank you for all that you do. I know that Reasons to Believe is an organization that mixes science and faith, and you do it so successfully. There are tons of books that our audiences can go to RTB, reasonstobelieve.org, and you can buy books there. You can read articles. You speak at different places. You speak to scientists. You speak to lay people. You are spreading the gospel 21st century style. And if you have enjoyed what you've heard today, you can go to reasonstobelieve.org, support them.
That's reasons.org.
Reasons.org. I've been going there for years, and yet there it is, not in the head. You can go to reasons.org. You can support them. You can buy books. You'll love it. Thank you, Hugh, and we'll look forward to next time. God bless you, and God bless you. Remember, like, share, and share that God story. God bless.
More SciTech Talk at MyMichelleLive.com.